Okay. Hi, everyone. Thank you all for joining us. A little bit about me. My name is Eslam Nasser. I'm an iOS developer located in Malmö, Sweden. I love reading fiction books mostly. I love watching cinema and like movies and series and everything. But the weird thing is, I haven't watched Star Trek or Star Wars. And yes, to answer your questions, I know they are two different things. And no, I don't know what the difference is. I love reading about psychology, human behavior, cultures, and everything. I love animals, especially cats, as you will come to see in this talk. My favorite snacks are cookies, Oreos, and if I'm not gonna get shamed for it, ice cream. Last week, I released a small personal project called Meow Meow. I worked on it back in 2020, and then I just abandoned the project and didn't release it. And then the beginning of last month, I brought it back to life and I released it last week. Also, last week I had the internal launch of another project, but I can't talk about it because it's not publicly launched yet. And also, I'm working as a contractor on another project that I also can't talk about. So I think in my next interview, this is how I'm gonna look with the interviewer. So when Marina, I think last week, posted that she's looking for speakers for the next event, I was actually working on improving the image performance of one of the projects that I can't talk about. And when I was working, I was thinking to myself, I should write an article about this because the things that I read on the internet and everything, and the things that I tried and found the difference with were amazing. And I thought of writing an article, but then when she posted, I was like, maybe give it a shot. And so she told me, can you prepare something for the next event? And when she asked me, the next event was after 10 days. And I had the launch of 2 projects, and I had other of tens of tasks on my hand. So the first thought was, no, I shouldn't take this. I shouldn't take one more thing and overwhelm myself. But I guess that wasn't my answer. Otherwise, I wouldn't be talking here with you. And so, you know what? It was fine because it's not like I overwhelmed myself or anything. It's fine. I finished all the tasks and I got enough sleep for the next week. And so I'm fine. Okay, so the story behind this is that a couple of weeks ago, I was assigned the ticket that one of the screens in one of the projects that I'm working on is lagging and it's not so performing very well with loading images. And the first thought that came to my mind when I saw that was, this is just unbelievable. It can't be happening. But then when I dig deeper into the problem and I saw what was happening, and I saw what was happening with SwiftUI and our setup, I started looking into solutions, but there was nothing straightforward about how to improve this or how to have some control over our scroll views or something. Anyway, so I tried a couple of things with a couple of solutions, and honestly, there was a lot of improvements that I'm gonna show you right now. But this is, I can see it that's just the first step that we can take. And so I hope that today you can come out of this with some tips that you can use in your own apps, and hopefully you can maybe the next time bring up some other tips that we can all use. And so today we're going to talk about a couple of things. So the first thing is going to talk about the blockers and the current issues that we have in the setup, or the setup that we're having, or in the most setups that we have. We're going to also talk about the framework called Nuke. We're going to talk about the obvious solutions and how these obvious solutions are not so obvious with SwiftUI. We're gonna then jump to the demo project where we're gonna add these changes to the project one step by step and see the differences. And then we're gonna move to some extras that you can add depending on your own situation and your own setup. And finally, we're gonna touch on the caveats, of course. So let's start. And yeah, before we start, let me show you the final results that we will have. So this is a recording of the starter project and the final project. And I think that you can see which one is the starter project and which one is the final project. And I think you can see the difference in the performance of them. And you would assume, or you would think that these are small images, but these are full, huge images with like 3 or 4 megabytes. And so I aim to, optimize the project to work with these huge images, but that's not gonna be the case for you. It's not like the project that you're working on, you get these huge images from your backend. But I try to do it with these large images because if we can optimize with the large images, you can only imagine how the app is gonna perform with your regular or small images. And so you can see that how it performs on different screen sizes and on different sizes of the images. And so yeah, that's what we're gonna do today. So let's start with that. But yeah, before that, a couple of disclaimers is that this demo or this talk is not focused on SwiftUI or like how it works by itself. It's just focused on solving this issue with loading images. And you can actually use this whether it's with SwiftUI or UIKit. It's powered by the library called Nuke that we're gonna talk about. And the last thing is that this is my first time working on something with performance with SwiftUI. Even though it's not perfect, but it's a huge improvement. So first thing we wanna talk about the blockers that we have. The first thing is that with SwiftUI, we don't have a direct access to our data sources. And by data sources, I mean, for example, in UIKit, we have UI collection view, data source, and all of these delegate calls that we can use to control and have some control or customization with our scroll views, or let me say lists in collection view. But in SwiftUI, we don't have that. And so this is the first thing. The second thing is that mostly when you are displaying your images, unless you are using a VStack, because mostly if you have a huge list with 100, 200 items, you're not gonna use a VStack. That's just gonna load it up all at once, and you don't want that. So you're mostly gonna use something like a lazy VStack or a lazy stack in general. And that will only, load your view when it starts appearing in the screen, which means that your image is only gonna start loading when it starts appearing in the screen, and that's not ideal. And the last issue is if you're using something to cache your images, if you're not careful, you might end up caching a huge image when you're using it just for a small view. So for example, if you have an image with like 500 by 500 pixels or like 300 kilobytes, and you're using it for this small view with only 60 by 60 pixels, it's just you're caching a huge image for something very small, and you're using more memory that you want. And so the result of these blockers is that we end up with loaders. A lot of loaders in our apps that just fill up your whole screen. And that's not what we want. So, yeah, okay. Let's jump and talk about Nuke. Who here has heard about Nuke framework? Raise your hand. Okay. Who here uses it in their personal projects or work projects? Okay. So I know that using a party library is not the most just straightforward or the most ideal way to load images, but honestly, I love Nuke, and the contributors behind this framework are just amazing. They're always working on improving the framework. They're always working on, making it just the best image loading framework that you can have. They even added support for Vision OS right after it was released. So it's not one of these frameworks that is just abandoned and if you use it in your apps. Plus, it has an amazing toolkit, powerful caching system, and the performance of this framework is just phenomenal. And it has a lot more to offer. So if you haven't checked it out, give it a try on your personal projects. Believe me, you won't regret it. Okay. With that out of the way, let's jump to our demo project. So we're gonna be working with our little demo project called Per Images. And let me give you just a quick overview of this project. If I run it here, we have a main view. Let me take this to here. Okay, so we have a main view with different kind of lists, grid, full, and everything. These are our list views, data service that gives us images from the Unsplash API, and this is our model. We don't care about most of these things. The only two places that we care about are the view model and this modifier called per image. This modifier is just a place where we have our lazy image, which is an API from Nuke, that you pass a request to it, or you pass an image URL to it, and it loads an image. It gives you a state, and you can switch to that state, whether it has an image, or it's loading, or it's an error. And I'm just trapping it with a modifier and using it in my views. We have the view model that we are using in our list views. It's just using that data service to load the images with pagination. So if I open up here, it loads, and then I go, and then it has different paginations. And so we're gonna do our work on this to add our improvements. And so, okay, the first thing that we're gonna use is something called image prefetcher, and by the name, you can see that what it does, it basically prefetches the images for you. And so we're gonna use that image prefetcher in our screen view model, but the thing is, this image prefetcher is actually, as you can see here from the Nuke documentation, it has like a support for UI collection view, and it works beautifully with it. And it's the obvious solution because it works with UI collection view data source prefetching. You can just use it here, get the URLs, and the UI collection view data source will just call this whenever it's about to prefetch the items. So it's the perfect thing to use in this situation, but unfortunately with SwiftUI, we don't have anything like that. And so we have to come up with our own hacky ways, just like with anything we do with SwiftUI. And so what we're gonna do today is that we're gonna have some, so the trick here is that you're gonna kind of be one step ahead from your user. And by that I mean, you're gonna always be one page, how do I say it, one page ahead of your user, so that you can have the chance to prefetch the images that the user is gonna be moving to. It's just a small trick to be able to get those images. And so the first thing that we're gonna do is, let me grab my snippets. We're gonna have these image requests that basically we're gonna store our image requests for the prefetching here. And we need this because each time we're gonna prefetch the images, we're gonna need to cancel the last prefetch images. At the same time, we need our, let's say, the next batch of data model. So basically, we're gonna store our next page for the user in this variable. And the last thing we need, which is the, let's see, no, which is, I can't find my, oh no, I think I lost it. Okay, we're gonna implement it by ourselves. That's okay. We're just gonna add the steps here. Okay, so the steps to do are that first of all we have our data batch and we have our last batch of images. We're gonna first have our prefetcher, and so we're gonna have a prefetcher here. Let's call it a prefetcher, which is a of image prefetcher, and we're gonna have it as an optional. And in our init, we're gonna initialize that image prefetcher. And we're not gonna use any customization. You can see here that you can have a lot of customizations. You can pass a pipeline destination where you can change your caching destination, but we're not gonna use any of that. And let's just use something called dit complete to know that we have completed prefetching. So this is the first thing. We need to also make sure that we are canceling all our prefetcher calls before after we de-init, or before we de-init, so that we don't have it keep prefetching after we have de-inited from here. Prefetcher, just a quick like this. Okay, now in our do block, the thing that we're gonna do is we're gonna check if our data is still empty, which means that this is our first call. So we're gonna append our images, and then we're gonna call the next page for our images, or for our data, which is we're gonna get viewed data with limit and limit. And we need a modifier here called should update boolean, and let's say true. We need this modifier because we're gonna call get view data again, and we don't want to update when we call it from here. So we're just gonna say false. Okay. Now, if our view data is not empty, we are just, here is where we are gonna do our prefetching, because it's the second time that we got our data, and this is actually where we are gonna do all of our prefetching. So the first thing is that you need image prefetcher. It has this, you can call start prefetching, and it has two parameters. You can use URLs or image request. I'm just gonna use the image request because later on we're gonna need to configure that image request. And so let me create the image URLs from here. Let's see. So we have our images. I wanna compact map. I want the image URL, and we're just gonna use the preferred size, selected size dot row value, and we're gonna have our compact map with image request with a URL here. So we can just pass our image URLs here. And then because we're gonna be calling this multiple times, we just need to cancel the last prefetch images. So we're gonna stop the last prefetch requests, and then we're gonna assign our last prefetched request to the image URLs, and the next data, we're gonna assign it to our images. And so, and then before, the last thing is that here, if should update. If we are gonna update our images from our views, we should just update the view model, the view data, append, but here we're gonna use our next batch data. Now, I'm sure this is not the correct way because contents of next batch data, yeah. I'm not sure of this, so I'll check it out later. Okay, now that we have the image prefetcher, let's move to the custom pipeline. And so Nuke has this something called a pipeline that it uses to load all of its images, and by default it uses the shared pipeline. But we can also create our own pipeline and with all of its configuration. And so if we move to here, and let me just grab my pipeline. There it is. We can create our own custom pipeline with all of its configurations. We have something called progressive decoding that I'm gonna talk about later, is using prepare for display, decompression available or enabled, and the storing previews in memory. And we can use this custom pipeline here by just calling pipeline. Pipeline, our custom pipeline, and that's it. That's all that it requires for you to pass your own custom pipeline. You can use this pipeline configuration to configure a lot of options with the Nuke library. You can check the configuration here with all of the things that you can do, and it all depends on your usage, but for now we're just gonna keep it simple with this. Okay, the next thing is caching size. So I talked about caching size and how sometimes we get large images, but we're gonna use them with our small views. So if you look here, for example, I have a list view, and this is just using a 32 by 32 size, 60 by 60. Here we have 130 and by 130. And when we are running this app and we are using the full size, these images are huge. And so it's not ideal that we are caching these huge images when we are using them for this small space. And we can actually solve this issue with Nuke with something called a processor. And so Nuke has this thing called a processor where you can apply for its requests. And so if we just create our requests here, yes, there it is. We use a processor and we use something called resize, and we can just pass any image size to it. Right now we don't have our image sizes, so let's just add image size. Let's see, CG size, and here let's say image size, so that because we're using this view model with different views, we're just gonna pass our size that we want, but ideally you will have your image size to be different in each one of these views. So here we are using 60 by 60, so we'll say 60 by 60. In our grid view, we are using 100 by 100, 130 by 130, so we're just gonna pass that so that we can use it in our processor. And finally, in our full view, we are using 370 by 300 by 200. So 370 by 200. Now, the only thing that you have to be careful about when using the processors is that if you are going to use any processors in your image requests, you need to use the same processor in your prefetcher. So now we have this request or this processor in our prefetcher. We need to use the same one here in our main call, because the thing that's gonna happen is that, as you can see here, there is a warning. So basically what's happening is that if you're not gonna use the processor and resize your images in your prefetcher, and you're only gonna use them in your requests, the prefetcher will call and get the data before the main request. And if you don't apply the processor there as well, when this main request calls the system, the nuke system, to get that image, it's only gonna get the image again from the main source, because for nuke, because we applied that processor and because we have it in a different size, that image is now different and it's stored differently in the cache. So even if you are prefetching your images and caching them, you're not gonna get them if you don't apply the same processor. And so what we can do here is just have a func to get the request with our URL. And so we're gonna have request image image request, let's say. Okay, so yeah, now we have our request, and because we don't have an image size, we're just gonna create another modifier here for the preferred image size here, and we're gonna replace our whole modifier with a new image size modifier. Preferred, there it is. Oh, okay. So now if we go back to our grid views, we can actually apply our processor to our modifiers, which means that we will have our processor applied in both places. I don't know why it's not calling init Xcode. Come on. We have 130 by 130. We have to apply this everywhere. This is not ideal, but this is not our focus right now. So preferred, yeah, init. We say 60 by 60, and we go to our full view and we apply it there as well. Preferred size, and we have 370 by 200. If we run the project, Xcode should fail. Yeah, so couldn't find image size. Why couldn't you find image size? Oh, yeah. It's still failing. Okay, come on, Xcode, you can do it. Okay, if let preferred size.
Image.
Yeah,
Yes.
yeah, it's preferred size. Can we do it?
Function should be there in request.
Yeah, the request. Thank you. Request, and we'll use it here. Get request with image URL. Can we do it now? Extra argument image URL. Okay, sorry. Okay. Come on. Okay, it's working. Thank you. So again, on the caching size and the processor, you just have to be careful when using the processors, as if you're gonna apply anything to your main requests here, you have to apply them also in your prefetcher. Now, the animations, so the goal when loading images is that you just want to load them and display them to the user as fast as possible. It's even better if you can load the images and add them to the screen before, or as fast as possible before they even appear on the screen. So we don't care about having animations. Now, Nuke previously had animations, and so when it switched between these different states with like image, loading, and the error, it used the default animation with some fade in, fade out. And sometimes using these small animations can add up, and it could make your UI that it's taking long to load. But recently they removed that, and now they don't have animations. So if you want animations, you have to opt in. But honestly, I wouldn't recommend that you have animations when you are switching between these states, because as I said, the goal is that you show the image as fast as possible. The goal is not to have the cell appear on the screen and then show an animation with the image, unless you have a very fancy animation in your design. But mostly that's not the case. So, yeah. Okay. The progressive decoding it's something that very cool, and it's basically the idea that instead of loading the whole image and then passing that image to you, it will basically start giving you every data that it receives. So for example, if you have 500 kilobytes of data with an image, the first when it loads the first 100 kilobytes, it's gonna pass you an image with those 100 kilobytes, and you can show it. And mostly it's gonna be this blurry image in your with these 100 kilobytes, and then when it receives the second one, it's gonna pass it until it's finally the full image. The thing is, while I was building this demo, I faced an issue where using the resizable modifier so that I can resize the images, it somehow made the progressive decoding behavior disappear. And if I don't use the resizable, the images will just be in all of these weird sizes. I don't know if this is an issue with my current setup with SwiftUI, or maybe it's a bug with the framework. Either way, if you try this out and you find a way to fix this, please let me know. You're gonna be my favorite person. So you can enable progressive decoding. It's not enabled by default. I think, yeah, it's false by default. So you can enable it with our configuration in the pipeline. So that's also a cool thing that you can do. The last small thing that you can use, which is something called a request priority. And with request priorities, you can basically change the priority of your request, whether it's a high priority or a low priority. Now, all the prefetchers have a priority of low by default, and the normal requests, any request that you create has a priority of normal. I wouldn't recommend changing that, but if you think that your screen needs to load the images as fast as possible, maybe you can change your prefetcher to have a priority of normal and your request to have a priority of high. But at the end, it depends on what you use or what you want from that screen. And so we're not gonna use the request priority here, but if you want, I could imagine that you can add a modifier or a property here called is high priority, and then you can change it here, and you can also change it in your prefetcher if you want. And so with these things out of the way, let's talk about some of the extras and the cherries on top that you can use. So the first thing is, be careful with using prepare for display. Now, I tried using this, and it's basically it says here in the documentation that when you set this to true, it uses the native prepare for display method for decompression on iOS and tvOS on 15 and later. It's disabled by default. I tried this to see what it does and how it works. I couldn't find the difference in the loading images, but the difference that I found is that it spiked up the memory usage like crazy. And that's why I'm mentioning it here, is that I'm saying be careful if you're gonna use this. I don't know what it is or what it does exactly. If you know, please let me know. But please be careful with it. It can really mess up your memory usage. Control your image sizes from the server side. So if you can control or request from your server or the backend different image sizes, this will also improve your image sizes or your image loading performance a lot. Because, for example, you could ask the backend to send you 3 image sizes: large, medium, small, and then you can use different images sizes depending on where you are using them in your app. The next thing is thumbnails. So Nuke has this thing called thumbnails where it generates a blurry image from your original image, and it passes that image to you and it caches that image. I tried it. I didn't like it. Maybe you want to try it out and see if it works with you. I just thought I should mention it to you. Prefetcher destination. I mentioned that in your prefetcher you can change the destination. And so it has disk cache and memory cache. The disk cache is, as it says here, it has it requires less CPU, but the caveat is that you can't. I don't remember where I saw it in the documentation, but the thing is, if you are applying any processors, you can't use the disk. You can't use the disk cache destination, and the framework is just gonna override it and use the memory cache. But if you're not using any processors, it might be a good idea that you change your destination to be in the disk cache, just so that you use less CPU. Create your URLs at the decoding in the background and not before the requests. Previously, in a previous setup, I used to pass the image URL string here and then create the URL here. But you could also improve your app CPU performance if you create your URLs in the background while also decoding. And finally, smaller pages means faster prefetcher. So here in our image prefetcher, when we request the next page, we're gonna as soon as we get that next page, we're gonna start prefetching its images. And if the user reaches the point where they need the next page and we request that next page, if the prefetcher is not done prefetching, we're gonna cancel it anyway. And so if you have smaller pages, the prefetcher is gonna be able to prefetch your images or complete prefetching your images before they are canceled here. And so you can honestly control this, and you can see it in your screen. If you have, for example, here you have 6 or 7 items, you can fit it in your screen. Maybe you can prefetch with the limit of 15 maybe or 10, so that you can give your prefetcher some room to actually prefetch all of the images before they are displayed. So with all of these things, what is the results of this? And I've shown you the results before, but I want to show you the results again with using different image sizes. And so we have this full image size, and as I mentioned before, these images are like 4 or 3 megabytes. And they're huge images. Like if you just download them in, open them on Safari or anything, it's just these huge images. But as you can see, they're honestly being downloaded relatively fast compared to their size. If we switch to the regular size, you're hardly noticing that they are being downloaded at all, as you can see. And the regular sizes are like 400, 500 kilobytes. And if we switch to the small, the performance is even better. And so that's why I told you at the beginning that we try to optimize using the full images, because if we can see the difference and we can see use these optimizations with these huge images, the performance when we are actually using smaller or regular images is way much better. And so I'm gonna upload this demo project later, and I'm gonna link for all the references, and I'm gonna have two demo projects. One is the starter project and one the final project, so that you can compare between them. But yeah, that is it. Thank you for listening. If you have any questions, or if you have any suggestions for me how I can improve on this, or any improvements, please shoot.
We have time for like 1 or 2 questions now.
Yeah.
And then we'll move on to the next one. So if anyone has questions, raise your hand.
How did you land on Nuke? Like, how did you find it? Like, did you consider using any other frameworks? Or?
I didn't try using it. So before we actually used Nuke in our project, we actually did a small research on what kind of image, you can say, image system that we wanted to use in our app. I think the two most famous frameworks are Nuke, and the second one's called SD Whip Image, I think. Yes. I liked Nuke because, as I mentioned, first of all, of the contributors and how they're always keeping the framework up to date, and also because if it's amazing performance and the toolkits that it provides for you, especially some things like the lazy image. Like I use the lazy image with SwiftUI, and I use it with UIKit, and they both work just amazingly. And so yeah, that's why we landed with it. Honestly, when I first used the framework, I didn't plan on using all of these optimizations that it offers, but when I was faced with the issue, I thought I would try to dig and see if Nuke offers any performance improvements. So yeah.
So when you have a long list of just page over page, does it then automatically handle the memory, like the memory warnings or anything?
Yes. So it's actually the slide. I don't know how it slipped, because I mentioned that we're gonna talk about the caveats. I don't know how the slide slipped. So one of the things that we did was the image resizing. When we used the processor to resize the image. And this is actually something good, because before we use the resizer or the processor, if you scroll down in, like, for example, after a couple of pages, and then you scroll up, right now, after we added the processor, you can see the images are still there. They're still cached. But before, because we were caching the original images, because they're huge, and when you page through a lot of pages, the system like Nuke reaches a point where it's like, oh no, I need to remove some of the old cache to put in like some new images. And so if you scroll down to the bottom of the list and then you go up, you're gonna see that the items are gonna start loading again because you used all of your memory. The caveat that I want to mention is that after I added all of these improvements, I saw some improvement with the memory usage of our app, but it's still, I believe, it's still using a lot of memory. And so this is the thing that I feel like I want to do more work on, is improving the memory usage with these improvements. Because right now I achieved the goal with like improving the image loading performance, but I don't want to do that on the price of the memory, especially if you have a huge app with a lot of memory consumption things. So yeah, that's it. Okay.
Yeah, thank you so
Thank
much.
you.